at VAM Organic Chemicals Limited, Construction Chemicals from 1996 to 1998. Then as a technical manager at RMC Readymix India Limited from 1999 to 2002. Then as a sales manager at RMC Readymix India Limited from 2002 to 2003. Then as a concrete technologist at Master Builders Technologies Al Khobar, Kingdom of Saudi Arabia from 2003 to 2004. Then as a quality assurance and quality control manager at Al Turki Cement Products LLC Sohar, Oman from 2004 to 2006. And as a general manager technical at RMC Readymix India Limited from 2007 to 2010. Then as a director marketing and technical of ECMAS ECMAS Construction Chemicals Private Limited from 2010 to 2019. At present, he is working as a director QCrete Readymix India Private Limited from 2019. And his training and certifications, concrete technology and construction course from City and Guilds Institute, London, from 1999 to 2000. He passed with the distinction. Then concrete technology and construction course from City and Guilds Institute, London, 2000 to 2001. He passed with distinction here also. He's a lead auditor course ISO 9001 completed, trained in England in concrete technology and various aspects of ready-mix business, participated in construction chemicals product training program of MBT in Dubai, got training in Italy, Slovenia on construction chemicals, got training in Israel in concrete technology, and his achievements, he published articles on concrete related topics in many national publications. He regularly gives lectures in NCBM, that is National Council for Building Materials, Hyderabad, and ESCI, that is Engineering Staff College of India, and many other engineering colleges. Given about 200 lectures in various institutions, conferences in last 10 years. He worked and helped in various international audits, also done external RMC MA audits. For his achievements, ICI Karnataka chapter recognized and honored for his contribution to concrete technology. This is a brief introduction of today's speaker, VR Kaushika. Sir, thank you. Over to Chairman.
Yes. Thank you, Secretary, for the wonderful introduction of the speaker. And at the same time, I would like to request all our attendees, participants, to kindly, I wouldn't say to switch off your mobile, but please put it in silent mode so that next 1 hour, we'll promise you, we'll close it by 8 o'clock. We'll see to it that you'll not get bored, and at the same time, let the mobile do not disturb the knowledge session, knowledge gaining session. Thank you. And over to our speaker of the day, Engineer VR Kaushika, sir. Yes, sir. Thank you.
Good evening. Thanks to Anil Baliga and Eknath sir of Indian Concrete Institute, Mangaluru, and on behalf of QCrete Readymix India Private Limited, myself, Kaushik, trying to share my experience through this webinar. I also welcome on board Mr. Shalli Fernandez, our MD of the company, who has given me opportunity to speak to this August gathering. So I will start with the understanding of strength issues in ready-mix concrete. We can say not only ready-mix concrete, also in any production site wherever concrete is produced. And these issues are not now, actually, it is not a new issue. It has started since the beginning of invention of cement by Joseph Asford in 1840s, and then eventually the RCC came into existence in 1867. On those days, the strength issues are there, and they will continue to be there because of multiple factors, which we are going to talk about factors today. Strength remains the primary parameter of evaluating concrete quality and fitness for purpose. So if any concrete producer has produced any concrete of any grade, the only proof that he has to prove that he has supplied the right concrete, fit for use, fit to match the requirement and specifications given by the customer, is the cube strength. So it is very essential to know the different factors which affect the concrete strength, and how we can reach the concrete strength to its maximum potential by various concrete quality control procedures. So I would like to present here what is given in IS as compliance parameters, which is also referred to popularly as acceptance criteria. So this acceptance criteria for cube strength is very simple and clear. If you have a set of cubes when you have done the concrete, right? Set of 4 consecutive cubes, each result should comprise of 3 individual cubes, and then the result, which is an average of set of 4 cubes or 4 results, should be FCK plus 0.825 into standard deviation, or FCK plus 3. An individual result can be FCK minus 3. Here individual result means average of 3 cubes. So this is a standard very clear indication of how IS defines the acceptance criteria. So we need to know this one before we move to low cube result or any such parameters. So I want to just tell you, instead of calling a result of when we have done the concrete or low or failure, a constructive approach should be to ask how far away the results are from the requirement. So instead of just labeling it as failure or low, which is a negative statement and a kind of a destructive comment, actually, we should be moving towards a constructive way of asking how far the result is. And we all know that it is a matter of only understanding how far the result is away from the requirement. Now, the cube issues or the strength issues, when we're talking about the strength issues, in other countries like USA, this is done in cylinders, whereas in countries like European countries and in India, we cast cubes actually. So we have different classifications to categorize different issues. One is intrinsic strength issues, which is you once the concrete has already this kind of an issue, you cannot do much about it. You have to take remedial treatment. You have to make remedial treatment. Here, the actual strength of concrete is not up to the mark. The other category is apparent strength issues. When we are testing or in any site, you can see some perception by somebody. Means during testing, you might have done some mistake, or some mistakes might have happened somewhere. So it appears at the surface level that there is a problem with the concrete. So these are apparent strength issues which may not be actual, which needs further investigation or understanding to really classify it as intrinsic strength issue. And of course, we have the post-production issues that happen later once the concrete is produced in the batching plant or in a central mixer. It is transported, and then when it goes to site or on the way to the site, during transit or after transit, during placement, how it is treated by the customers. In such cases, it may lead to some problems of strength, and those are classified as post-production issues. So intrinsic strength issues, we go step by step. Here, the defects can be classified again into material quality defects, variations in properties, water cement ratio errors, batching inaccuracies, and design inadequacies. So material quality defects will deal with substandard materials, either cement or supplementary cementitious materials or aggregates, which don't meet the specifications. And then the other one is property variations, significant deviations in the cementitious material itself, and then which were never there during the trials. And of course, the most serious issues which cause intrinsic strength issues. Probably one of the reports when a survey was done for failures of cube strengths in Australia way back in between 1995 to 2005. The survey report showed that based on the cube results collected in Australia, the 90% were mostly belonging to water cement ratio errors. Intrinsic, I'm talking about the intrinsic strength issues. So when the water cement ratio goes wrong, definitely strength issue comes, because we all know the fundamental law of the strength, that is, the strength is inversely proportional to water cement ratio. So if the water cement ratio is compromised, concrete will definitely show a later at a later age. I mean to say, after 7 days or 28 days, you find problems with the strength. Batching accuracies are there, inaccurate proportioning of ingredients during production, which can lead to mixed composition, deviate from approved designs, and design inadequacies. Okay, we'll go one by one in this as we move along. We take the issues with our basic ingredients. We know cement is the basic binder, and through the world, the concrete world is completely governed by the strength of cement and what the cement contributes to the concrete. And of course, we have, starting from in India case, starting from 1995 onwards, especially during 2000 onwards, emergence of large usage of fly ash and GGBS, and these are all called as cementitious systems. and we go one by one. What happens when we have substandard material? When we talk about cement, cement is produced as per standard in India and elsewhere, and the significant development in R&D and a lot of modern equipments used in the quality control procedures of cement manufacturing, and then later on analyzing the cement, have made significant strides in the quality control of cement. Thus said, still we have issues with the cement. For example, uh, we we uh, we had seen way back in 1990 to 93, when I was working as a application engineer, just learning about concrete. For example, we take an admixture, we can make a mix design today, we cast the cubes, we take this lump today, and next day, same bag. For example, we have same brand, different bag we take to make similar trial just to validate the previous day's results in terms of slump and slump retention. The results were different, used to be different. So cement, when it is being produced in large quantities, 1,000 to 5,000 tons or maybe more in a patching plant per day, the uniformity sometimes may not be there. I'm not telling it is an everyday activity, but many times it is not as uniform as it is expected. Batch to batch changes can occur. Source to source changes can occur. Brand to brand changes can occur in the cement quality. And we know that, for example, the limestone, when it is used today and when it is used after 3 months or 6 months, it will not be of the same quality if you are taking from the same quarry. There will be some changes, and in spite of the best modern equipment, some companies using robotic equipments to analyze and make better product and give consistent product, we get inconsistencies in cement, which are related to consistency of cement, which are related to composition, which are related to strength, which will lead to some strength issues and cause significant variation in the concrete strength. Uh, this article by Michael Fremantle in 1998 still seems to be valid. The properties of cement can vary in an alarming manner from manufacturer to manufacturer, and even from batch to batch from any single producer, he pointed out. He added that even a small variation in the chemical composition or physical state of cement can cause substantial variations in performance, usually in ways that cannot be foreseen at all. So he has named this in this article as joys of cement. It is not joys of cement. It is really sorrow caused by cement for the concrete producers, especially the QAQC people. They suffer a lot because of these variations. Uh, uh, the problem is, it is not that cement meets the standard, particular standard, Indian standard or anywhere else the standard. The problem is that when you are making a ready mix concrete, we want to transport for 1 hour, 2 hours, 3 hours. There are interactions, multiple interactions with the other materials, including SCMs plus admixtures, which makes the final properties of concrete, both in fresh and hardened state, completely different and completely unforeseen, as this man says. Yeah. So it is very complex from to understand the variations and expect the variations, and we have to be very careful when we are making concrete and be cautious about the main binder, which is cement. I'm just putting across two cement reports, okay, which are which are lower uh, in means which were collected across in this year only from some companies. There are two reports. You can see the 28-day strength is lesser. Here you can see both the 3 days and 7 days and 28-day strength all are lesser. So this is only shown to indicate there are variations which occur in cement as it occurs in any other ingredient of concrete. So coming to fly ash, fly ash is a waste material. Nobody takes responsibility for fly ash once it is taken from thermal power plant, produced in thermal power plant. It is brought in bulkers and given to ready-mix companies. And the variations in fly ash, fineness, particle size, all can cause effect on the concrete. It can also affect the pozzolanic reactivity, which will indirectly affect on the strength of concrete and durability of concrete. So fly ash, basically, ready-mix concrete producers or any concrete producers will do the fineness test, and the surface area is very important. And the reactivity and pozzolanic reactivity and the effectiveness of fly ash is dependent on the surface area. So 45 microns is test is done, okay, and it should be greater than 34%, when retention should be more than 34, not more than 34%, when it is sieved on a 45 micron sieve. For GGBs, it is 20%, and the glassy material, which is L2O3, SiO2, and Fe2O3, and CaO, both in fly ash and GGBS, will vary. More variations occur in fly ash because it is a it is a material which is having no quality assurance from anybody, because it is a absolute waste for a thermal power plant. And GGBS also varies in the composition, chemistry, and both in physical and chemically. So we have to be careful. The CaO content in both the cases vary. If you take fly ash, there are class F and class C fly ash, and in GGBS, you have sometimes variations in CaO and class C content of the of the GGBS, leads to both problems in fresh and hardened properties, especially leading to lower strength. Fly ash, if you can go deeper, the carbon content in fly ash makes the admixture levels go up, or rather water level go up, which leads to lower strength of concrete. The sphericity of fly ash is the one which is an attractive when we are using fly ash, but many times the coarser particles will be kind of a inert material, and they sit as dead particles in the concrete without reacting, without participating in the pozzolanic reactions, leading to lower strengths. So the quality control of fly ash and GGBS and observing these batch to batch is important. Coarse aggregates, as we know, uh, the crushing value, impact value, and all are important. And then the grading should be uh, uniform. Grading should be tested as per 383. And then we should also have an eye on the flakiness and elongation. Flaky materials and elongated materials will give workability issues, which may cause water demand go up. And you have sometimes intrusion of organic materials and other things which may affect the concrete strength. Similarly, fine aggregates, the as the name suggests, fine aggregates, when they become very fine, especially if you are using a crushed rock fine or manufactured sand, which is a definitely a derivative of the stone industry, You have 75 microns down, 150 microns down, 75 microns down. If it goes beyond 15% and tending towards 20% and beyond, sometimes you will have water demand going up, and then the texture and shape of these particles also will have problems. All of these coarse and fine aggregates, if the specific gravity is more, specific gravity is lesser, and the absorption value is more, it will lead to lower strength. Natural sand many times contain organic and many other uh, mm, contaminations like high amount of clay and silt, which may interfere with the bonding of the sand matrix, aggregate matrix, and then sometimes high amount of fines in both uh, the manufactured sand, CRF, and river sand may hinder the progression of hydration of cement, leading to lower strength. So the quality control of all these materials is very, very crucial before we move into the other aspects of strength of concrete. Water also is equally important. Water is many times neglected. Water has to be potable water when you are mixing, and then if you have more chlorides in the water, it may accelerate the setting time. But whenever this kind of chlorides present, they not only affect the ultimate strength or the concrete mixes do not gain the potential strength which is it has been designed, but it will also suffer due to the presence of chlorides because of it participates in the corrosion aspects, and the rusting which is formed inside the body of concrete pushes the concrete and away, and then it causes deterioration. So water is very, very important aspect, and water has to be controlled as per the highest standard, and also it should be potable water. We have to use good water for making concrete. There is no compromise on this. So as I said, the beautiful article, I am very much fascinated by the way this man has written. I request audience to go through this article whenever you are free. Next, what are the other problems that can occur apart from the materials? You start doing mix design as per IS standard or any standard, then you select wrong materials. You select bad sources of material, which you have already talked about the materials. And for example, some people are fascinated by what they have done in the past. For example, somebody has done a mix design for M45 or M50 at 450 kgs, simply specifying 450 kgs based on his old experience, old data may not work. For example, somebody has done mix design based on OPC here. Same thing he cannot do with a different source, a different brand of cement somewhere else. And we should also be careful that if we have done the mix design with a set of materials today, these same materials has to be used during the implementation of concrete production actually. So today we do with set of materials, one admixture we take, one brand of cement we take, and then you change it during the process of production and casting of concrete. Definitely, somebody can say cement is a cement, but it is not like that. So ingredients can change, hills can change, and which can affect as the project progresses. The results of strength results may be different. You should not have permanent mix designs. For example, a project is running for 4 years. It is not necessary that we have done a M40 mix at the beginning of the project with some trial mixes. You cannot have the same thing for 4 years because materials will change, all the ingredients will change. They may change most likely. So you have your mix design has to be based on your observation of the cube results, and then you also observe this lump, both fresh and hardened properties, and this is referred to as the retrospective control. Mixed design done without understanding customer requirements. Say, for example, we just take the mixed design. We just do the mixed design without understanding what the customer wants. Whether the customer wants to de-shutter the concrete in 7 days, de-shutter the concrete in 3 days, or whether it is a raft, whether the raft is too big. Should we consider the thermal ingredient and heat development, heat hydration, etc.? All these things have to be listened to before we jump into mix design. Non-standard mixes. So simply, any mix design, if you look deeply, it is a set of numbers actually. So these set of numbers has to be backed by solid practical experience of the concrete mix designer. So if it is not done, and if it is based on simple random methods, it may not work. And also we should not go for prescribed mixes. For example, some of the customers will say, my project, you use 70-30 mix, 80-20 mix, as per whatever probably their experience or their interest is, or what they know about, without leaving the matter to the concrete engineers or concrete designers who are doing this job day in and day out. So this may also cause some mixed design issues, especially you may get this trend, you may be compromising on the fresh and the pumpability and things like that, or you may get the fresh properties right, but hardened properties may be different. So these are mixed design related issues which may lead to problems of strength. So apparent strength issues are like, as we said, these are basically happen because of mistakes that we do during production, after production, and then the QAQC procedures. If there is a problem with the QAQC procedures, then we have we get a perception, or we see that the material that we supplied or the concrete that we supplied may not have met the requirements. Okay, our customer may see like that, but actually it might have met the requirements. So these are apparent issues. So it is generally related to non-standard sampling, inadequate sample mixing. Some of the smaller issues, somebody may think it is a small issue, mold releasing agent not properly selected, improper curing conditions. So these are some of the issues. Now we come across people who day in and out we do the concrete production and delivery. There is a standard procedure for taking sample, which very clearly says, as per PS standard, if you are taking a 6 metric cube truck, first metric cube has to be left, last metric cube have to be left, and in between we should run the scoop and take the sufficient concrete for taking for making sample for cubes as well as taking slab. So this is called as a standard composite sample, whereas the ASTM standard says 10%. First 10% you leave, last 10% you leave when the truck is reached the site. First you mix thoroughly with high RPM, and then after thorough mixing for 2-3 minutes, then you leave the first 10%, last 10%, take the concrete in between for sample. Sufficient sample has to be taken for sample. So what they specifically say is, when you take such a sample, you can take slump test and you can take okay. So this is a standard. The highest standard, on the other hand, says first you have to leave 0.3 cubic meters when the concrete has mixed, and then when it is going down the chute, you leave first 0.3 cubic meters, and then you take the concrete sample at regular intervals. This is what the IS says. This is similar to alternate method which is specified in BS, which is also called as spot sampling or alternative sample method, where we leave the 0.3 cubic meters and just take sample as the concrete is moving down the chute for assessing this lump. Here we need to know the BS very specifically clearly gives in the standard, sets the standard here, says that the spot sampling or alternative sampling is only for making slump test, not for taking cube. Whereas Indian standard, which we know, talks about taking sample after 0.3 cubic meters is discharged. Whatever standard we use, let us stick to the standard and do the job. And if you do in any unstandard method, if you do in any unstandard way, the sample will not be representative sample. So why we should take, for example, we are doing any test. For example, we take aggregate test, we do any test for that matter in concrete or in any other field also. For example, somebody is manufacturing a biscuit factory is there. So how we have to take sample before we send the material for packing and then to the customer. There is a standard. You have to use that standard. Similarly, you have to use this standard for making sampling. And we know this slump test, 25 strokes, 3 layers, and then for casting cubes, 35 strokes, 3 layers. So this is very important to know that even though it looks very simple, it will lead to, if we don't stick to this one, it will lead to apparent strength differences, or somebody may become skeptical and somebody may start thinking whether we have got the right concrete or not. So when we do cubes, when we cast the cubes, follow the procedure, properly mix the concrete which you have taken, very simple, and then the cubes have to be transported to a place where you have a curing facility, and the curing facility, the water has to be at 27 plus or minus 2 degrees as per Indian standard. So the Indian standard very clearly here says as per 4926, 0.3 cubic meter we have to leave, and then we have to take at least 4 incremental samples from the remainder of the load. So this is how the sampling is done, and it has to be, we have to stick to this sampling procedure. So testing equipment and procedures error, we have uncalibrated testing machines, incorrect loading rates, improper specimen placement, uncomplained molding. So these are, if you look at these things actually, some of the test houses or even the testing centers, ready-mix companies, where they test samples, they don't have calibrated machines. Some old machines are there, which will not give proper loading rate, and then it will lead to lower strength or higher strength, which is which will lead to an apparent failure of or low cube or high cube results actually. Cube molds have to be maintained properly. Cube molds have to be prepared. Means cube molds have to be checked for compliance. 150 mm by 150 mm by 150 mm. Very important. Curing room has to be like this. Actually, it has to be properly made, where you use thermostats in winters, and then you have this water is drying. You heat the water in winter, low temperature situations, and in summers you run AC, so that the water temperature is 27 plus or minus 2 degrees. So in India it is 27 plus or minus 2 degrees. In USA it is 23 plus or minus 2 degrees. In England it is 22 plus or minus 2 degrees, or 20 plus or minus 2 degrees. Like this, each standard has a specific temperature range where it has to be cured actually. Okay. And costing of the when we are casting the sample cubes. Okay, somebody will say, I will take on the rooftop, I will take the concrete when the concrete is coming out of the pump. These are all unstandard methods actually. It has to be taken when the concrete is being pumped, is falling onto the pump from the chute after thorough mixing, or if it is a manual mix, or if it is a dumping mix, when the concrete is being dumped actually, when the concrete is flowing down the chute, it has to be taken. This, all the standards in the world say like this. So you cannot take the concrete, you cannot ask a technician to go to the 8th floor and collect the sample through the pump pipeline and cast the cubes, which some people do, some people insist actually. And very clear, the IS 4926 very clearly gives the frequency of sampling is for 50 batches or 50 metric cubes, one set of sample, which is 6 cubes, 3 for 7 days and 3 for 28 days. Okay. So if we take one sample means 1 cube, it is not a standard actually. Each truck taking one sample, randomly asking you take 2 cubes in this, or when the concrete is already discharged almost, at the end there is some flurry. If the customer takes the cubes in that kind of situation without following a proper procedure as described here, it may lead to apparent strength issues. So J.D. Dever and Anderson, two Britishers who worked extensively on cube strength, who studied the different effects, each of the operations that are associated, which can be classified as apparent strength issues, give the data like this actually. Here you can see sampling error. So many times we hear this sir, we are doing this sampling and testing of cubes for 20 years. We have trained technicians and all this we hear actually, but unless otherwise we stick to the standard procedures, especially in sampling, making cubes, remixing the sample, it will lead to a lot of apparent issues which may become nightmare for many associated people or stakeholders, because your activity will be from how to prove this apparent low cube or unacceptable cube result to a acceptable cube result. So you have to invest a lot of time and then spend a lot of money also to prove the convert that from an apparent issue to an acceptable cube strength. So here sampling error. If the sample is not taken properly from the truck, then it may lead to a positive swing or negative swing. Failure to remix the sample will be negative, which is about 18 to 20% down. Distorted cube molds, lack of mold oil, very if somebody uses a bad mold oil, it may lead to it may have an effect in the initial stage itself on the surface. You may see a lot of bubbles, air bubbles, and it may also sometimes react with the surface of concrete, leading to surface erosion or surface retardation, and it may affect the strength. Sometimes even 1 MPa, 2 MPa will make a difference in acceptance or not acceptance. So it is very important that we use the right oil. There are many companies who are supplying good mold release agent. We have to use standard mold release agent. Incomplete compaction. Every 1% of air which is not removed from the body of concrete during compaction, which is a result of sometimes somebody not giving proper strokes. The IS, we have to note, says that when we are doing casting of concrete, 35 strokes minimum 35 strokes, it says. So you have to do 35 strokes minimum, and then the strokes have to be distributed properly, and you have to use strength, not just touching the concrete. And then when you are casting in 3 layers, when you are casting the second layer, the concrete, the rod with which you are casting, it should just touch the first layer, and there should be a connectivity. Means it should be continuous. Means if you just poke without any strength, that is not vibration. You are not removing air. As I said, each 1% of unremoved air content will lead to 5% drop in strength. So if somebody has not compacted properly, let us say 5% voids are there, it may lead to 25 to 30% loss of strength, which is apparent loss of strength. And this may be same case in say site also. If the compaction is not done in site properly, it may lead to similar issues. Curing temperature outside the permitted range. So concrete mix design is done, and then cubes are cast, cubes are cured at a standard temperature as per Indian standard 27 plus or minus 2 degrees. So when somebody is curing at a different temperature, for example, now in Delhi, the temperature is in the night maybe around 6 degrees or 5 degrees or just below 10 degrees. Okay. So when the concrete trial mixes were done, the temperature probably was 30 degrees or 25 degrees, whatever it is. Then it was cured at 27 plus or minus 2 degrees. But when you are supplying the concrete, if the cubes are not cured as per 27 plus or minus 2 degrees, very low temperature if it is cured, the hydration process is derailed. The reaction between cement and water is a function of temperature. If the temperature is very low, the reactions will not go on this same speed. On the other hand, if the temperature is elevated, let us say the temperature is 45 degrees, for example, in a place like Ramagundam, the reactions are very fast, leading to quick gain of strength, but the ultimate strength will suffer. So in both the cases, when the temperature are lower or higher, the concrete will not meet the potential strength it is desired to. The strength in low temperatures, especially now, for example, winter, we see lower strengths in the winter because of slow reactions, and slowly when the temperature, when this kind of winter is there, the gain of strength will be slow, but it will effectively after 28 days or 28 days, it will meet the requirements when the temperature is right as per IS. So it will meet the requirements if it is cured in proper temperature, and the curing should not be intermittent. Curing should be continuous. So if there are columns on site, if somebody pours water in the morning, comes back in the afternoon, again pours some water and goes, if there is intermittent curing, it is more dangerous than continuous curing. Okay, so we have to have a proper curing regime actually. Many times it happens that, for example, in big projects, today columns are cast. Then, for example, let us say in the morning of today, they have cast actually, and they de-shutter tomorrow by, say, for example, 11 o'clock or 12 o'clock when the temperatures are high. And then after de-shuttering, it is not attended to because many columns they have to de-shutter. So they start curing after 1 day or 2 days. So you will get lower strength actually. Similarly, it happens in the cubes also. If the cubes are not transported to curing tank in time, if it is not covered with a polythene sheet and moisture escapes, then you bring later after 2 days and start curing. It is like, you don't give proper food in the beginning for a child. So it will show a stunted growth. The bones and the development of body will not be proper as required. Okay. So whatever you do later, you go on giving proteins, you do whatever you want. Later on, the growth may not be good. So it will be what is called as malnutrition. Similarly, the curing has to be done properly. Initial curing is very, very, very important that we have to take care. So faulty cube location in mission which is if we are not properly keeping the tube, it will lead to eccentric loading, leading to failure. Again, apparent strength, low strength. Faulty test machine, as we discussed, if you are operating a very old machine, because because the machine is being operated and we are emotionally connected for 20 years. Since 20 years, I'm using this one. Let me use the same machine without calibration or with calibration. Such kind of, if you have an attachment with a old machine, it may not give a proper result unless otherwise it is rectified, calibrated properly. So post-production strength issues. What are the issues that occur? Is an important point actually. Inadequate consolidation. So we already discussed, if the vibration is not proper, improper curing practices on site, or that may lead to problem. One of the major issues across India in many cases is unauthorized water addition. This water addition, mix design is done, and mix design is done with a lot of care, and we send the concrete to the site. And for example, somebody will add the concrete, water, maybe after 1 hour or 2 hours, because slightly slump is less or anything, without considering the fact that by adding a chemical admixture, you can boost the slump. So if that is not considered and simply somebody adds water, or for example, it can happen also by a ready mix truck. If the nozzle is not tightened properly, water can fall into the concrete, and it may give finishability, pumpability, and good placeability, but it will cause strength issues. So unauthorized water addition, if any water is added to the concrete, you are disturbing the concrete and you are lowering the concrete strength and durability. That we have to be very clear. Excessive delivery time, for example, as per IS 4926, once the concrete is batched, the concrete has to be placed, or the truck has to unload the concrete within 2 hours, unless otherwise it is added with chemical admixtures. And the chemical admixtures preferably be in the type G admixture, which are superplasticizers cum retarder. If you don't use superplasticizer cum retarders, which generally most of the remix companies use, and if you are not using, and if you are not doing concrete in a rainy day or a winter day where the temperatures are cold, the slump loss will be high, and you will end up with low slump concrete being poured, and you are disturbing the concrete when you are placing it after 3 hours or 4 hours, when the initial stage of setting has already started actually. So if you are placing the concrete later, as late as possible, if you are making it for 3 hours, 4 hours, 5 hours, especially if your placement is later, for high strength concretes, M40s, M50s, where the OPC content and cementitious content is very high, you have problems because the reactions are very fast in high strength concretes when compared to low strength concretes. So we have to be very careful that we have to unload the concrete as early as possible. As I said, again, I repeat, IS 4926 specifies that once the concrete is bagged, it has to be unloaded in 2 hours, unless otherwise it is incorporated with superplasticizer cum retarder or type G admixture, or you are doing concrete in a low temperature situation, like on a very high rainy day or on a winter day where the temperatures are low, or you are using a totally special admixture which can take the concrete for 4 hours, 5 hours slump retention, and you have data for that, then only you can use the concrete for beyond certain stage. And also IS 4926 specifically gives another class which says that once the truck reaches the site, you have to unload the concrete in 30 minutes. You cannot hold the truck for a long time. Longer you hold, you are disturbing the concrete properties, both its fresh and hardened properties. You are abusing the concrete. So we need to be very careful about delivery time. And then sometimes we get unplanned joints. Actually, joints are not planned, and construction joints and contraction joints are not planned, and then you have problems with strength. So these are field practices. What happens in field? Impact on quality management, effective QAQC systems, comprehensive understanding of these three issue categories enables quality teams to rapidly diagnose the true nature of reported strength problems, implement appropriate corrective actions based on root cause, prevent recurring issues through targeted process improvements, maintain productive relationships between producers and customers, ensure fair assessment of and equitable resolution of quality disputes. So we have systematic investigation, where always investigate before concluding strength deficiency, as we started our dialogue, that you have to first know how far your result is instead of talking about low result or failure, that words. Strict compliance with sampling, curing and testing standards, proper categorization of issues, ensure justice for both RMC producers and customers, maintaining trust and professional relationships. So what are the things that we have to do? Control of cementitious materials, and then we have control of non-cementitious materials, control of equipments, batching accuracy is important. We have the guidelines issued by IS 4926, where it says the batching tolerance is plus or minus 2% for cementitious materials and plus or 3 minus for other materials. So mixed designs have to be validated, approved. Water control is very important. Control of water cemetery is most important. Control of irregularities in slump and strength is important. Control of concrete post-production practices are important. And interestingly, BS 8500 very clearly, especially talks about long-term strength. So even if the strength is not good in 28-day strengths, or not good, not up to the mark, so there are considerations based on site requirements, based on your experimental data. If you have proper data, it can be used actually. So these are big buildings, tall buildings, skyscrapers in Toronto in 1980s itself, where the compressive strength was specified 90 days instead of standard 28 days. That allowed the incorporation of pozzolanic metal. So this allowed lower amount of usage of OPC, higher amount of pozzolanic materials, lower 28-day strength, but higher 90-day strength. The specification was the structure has to meet the requirements, tubes have to meet the requirements, concrete has to meet the requirements in 90 days. Similarly, Petronas Twin Towers, where the specification was often linked to 56 or 91 days, results on account for lower strength gain of certain cement types. So BS 8500 very clearly says, and there are other codes also. And now we have a lot of data in India also that long-term strengths are acceptable. So what we can say is low cube strength is not a low cube strength unless it is investigated, unless it is properly studied. And most of the cases it can be apparent strength and it may not be intrinsic strength. So we need to be judiciously taking a final conclusion or consideration whether the concrete is acceptable to or not. And we know we have to understand that concrete as a material tolerates nonsense to a particular limit. Too much abuse of concrete, like addition of water and meddling with it and not handling it properly, either during production or during transit or later during post construction. Sorry, I meant to say post pouring, during compaction or curing. If it is not handled properly, it will definitely not forgive. The strength will be shown, and we will have to do a lot of tests and invest time. So uh, through this medium, I request all of the audience to take care of the concrete. It is not only just doing mix design. Everybody should be on their toes when you are producing and placing concrete, transporting concrete in all aspects. Thank you very much. Any questions are there? We can talk. Thank you.
Thank you very much, Kaushika sir. Now, I request all the participants kindly, there's a text box. I think by now there would have been many questions in the text box, and otherwise, kindly enter your question and answer session. This session is on. Enter your questions in the text box. So we'll try to answer. And yes, sir. Meanwhile, Kaushika sir, it was a wonderful session, very enlightening, and a lot of information. Even I got it for first time. Thank you so much. Yeah, you can get the question, sir, in the text box.
I'm not able to see. If somebody can see, we can also. Any question?
If it is not visible, can we ask our participants to ask one by one?
Yeah.
By switching on their mic?
Yes.
Participants, kindly request you to ask your doubts to the speaker. I think you will have.
Hello, sir.
I can see. Yeah.
Yes, yes. Thank you.
Hello.
So namaste.
Namaste. I'm Dr. Dada Patel from Mumbai.
Yes, sir.
Sir, actually now, whatever IS code talks or even academically or even in the industry, we only keep talking about cubes. But my question is, anyhow on the site, we vigorously fill the cube with all the compaction. I am talking on the site, means we take the concrete correctly and we fill it correctly, we compact it. But what is the guarantee that whatever is in the cube, same concrete is on the site? So what I want to tell is, even the strict supervision and quality control on the site is also equally important, because boards keep on talking about boards keep on talking about cubes only. But whether it is really reflecting in the actual site also, is there any such thing which are come in future?
Yes, sir. Sir, thanks, Dada Patil Sab, for asking this question. My point is, the standard says you have to do things in right way as per the standard. So once you do the mix design, once you do for in Readymix concrete or any producer, he will do what is called as forward control, intermediate control, and retrospective control as per AS 496. One, it is done as per procedures and standards. And once the concrete cubes are cast as per standard, if it gives a proper strength, it is said that the strengths are okay. But for example, like say for example, you have concrete laid onto the slab. If the curing has to be done, if you are having OPC plus PFE or OPC plus GGBS, SCMs, you have to do this for longer time, 14 days, 10 days. And if, say, for example, somebody does in for 3 days or 2 days or 1 day and suddenly raises the columns and goes ahead because he wants to construct the, do the construction faster. If it doesn't take care of curing properly, definitely the strength will suffer actually. So strengths on site may be varied actually because of many practices like this. So many times there will be a variation. So we need to understand that the supervision should be of highest level on site. Then only the actual the concrete strength will be good.
Thank you, sir.
Yes.
One more question, short question.
Yes.
Sir, actually, we test at 28 days, but seldom the structures are put into practice at 28 days. They are put into practice after maybe 1 year, something like that. So why the code people are not thinking that 90 days strength so that we can use SCMs, we can take use of supplementary cementitious materials. Of course, you mentioned in one of the PPTs, but why they don't make it that why we are so much hell bent on 28 days only, whereas the structure is actually put into use much later. It is not put into use after 28 days. So maybe that should come into code. That is what I'm saying in future, that 90 days or beyond 90 days strength, so that it will become economical as well as we can use more SCMs for that. What is your view?
Sir, Dadar Patil sir, the one person by name Bryant Matthew in USA told in 1980s that OPC will be found in museum in 1980s. Okay, and in 1980s in Canada, I gave an example where the specification has been done for 90-day strength, and there are a lot of structures already built with SCMs with good amount of SCM using high, like for example, good quality fly ash after proper design and proper analysis of results. Already structures are standing for more than 50 years now. So there are people around the world who are bothered about too much about sustainability, carbon dioxide reductions, and usage of materials like fly ash and GGBS, usage of lesser water. Like this, these are called as SDG goals, which is Sustainability Development Goals. Every country has some targets actually, but we are still moving towards that one. I'm not telling nothing is done. There are consultants and engineers who are appreciating the long-term strengths actually, but unfortunately, it is not fully implemented. It may take some time actually. But we have found for example, in our company, Readymix company, we take on a weekly basis long-term strength for one set of cubes for 7 days, 28 days, 90 days, and 56 days, and we have a lot of data, so which indicates that, as you said, there is no point in specifying 28 days strength when the structure is going to be occupied after 3 months or 6 months, when the full loads are going to come at that time. So these things are going to come. Definitely, these changes will happen actually. A lot of awareness has come, and I'm very optimistic that sooner or later, long-term specifications of trends will be in action, which will be good for this planet, which will be good for sustainability and carbon dioxide reductions. Yes.
Thank you, sir. Thank you.
Thank you. Mr. Naveen Kumar is asking if I got strength more than FCK but less than FCK plus 4. So my question is this strength is acceptable? Sir, Mr. Naveen Kumar, IS 456 gives clear indications. So we have to completely analyze the data actually. So one, the mean of 4 results. Each result is average of 3 cubes, should be FCK plus 3, and then none of the result should be less than FCK minus 3. This has to be seen actually, means we have to analyze this one by proper studies. Then only we can come to conclusion. Yes, sir. Okay, sir. So in the end of the slides, I have given my email ID and mobile number, and you have QCrete mail ID. Anybody can ask the question later also. Not a problem.
Kaushika sir, shall we move to the next part of the agenda?
Yes, sir. Yes, sir. Thanks a lot. Thanks once again to ICA Mangaluru and our MD Shelly Fernandez, QCrete Readymix India Private Limited, for giving me as an opportunity to speak and share my experience. Thanks a lot. Namaste. Yeah. Yes, sir.
Yes. Dear friends, I think the marathon has just begun, and we have started this marathon with Kaushika sir, where ICI Mangaluru Center and QCrete Readymix India Private Limited, we are planning to host a series of technical lectures through this webinar mode, and I would like to thank and congratulate Kaushika sir for a wonderful and informative session. And without wasting time, we'll go to the last part of this today's program, that is a vote of thanks. Shall I request the MD of QCrete Readymix India Private Limited, that is my good friend and my colleague, Mr. Shelly Fernandez, to do the honor. Thank you so much. Shelly sir. Mr. Shelly Fernandez, can you hear? Hello? Mr. Shelly Fernandez, can you?
Sir. Namaste.
Kaushik, sir.
Yes, yes, sir. Balige sir, some network issues with Shelly sir. You can yourself conclude. Sorry if you don't.
Shall we wait for some time, sir?
Balige sir.
Yes.
Shelly sir has some network issues. Maybe you yourself better to do the closing.
Vote of thanks?
Yes,
Yes.
sir.
Okay. Thank you so much.
Thank you.
Um, so all good things shall come to an end. And today it's our first webinar and the first project ever since the revival of Mangaluru Center. And I'm the chairman, Anil Baliga, and we all members of the Mangaluru Center are very happy, and we are, it's our kind of a activity to start with. We had a wonderful way of starting this events with a collaboration of QCrete India, and wonderful to see so many people. And right now I can see about 114, and I was wondering in between it went about 160 or 170 odd. Anyway, still people are there, and I would like to take this opportunity to thank my colleague, my guide, and my friend, Mr. Kaushika sir, uh, uh, for this wonderful session. I think a lot of information we have heard from him, and definitely, all these informations are not available, in any kind of single place. These are the information which is acquired by experiences and different places. So would love to thank Kaushika sir for your valuable time and the willingness to share the information. I think that is more important. And at the same time, I would like to thank QCrete Readymix India Private Limited to come up with such an idea so that the knowledge, it is being shared. So thank you so much, both Kaushika sir and QCrete Readymix for this opportunity. And at the same time, I would like to thank uh, all the participants and the invitees in this forum for spending your about hours time with us. And definitely, when we are logging out, our knowledge level would have been a little better than what it was 1 hour earlier. Right. So I would like to also thank my chapters members who are have been a part of this activity. And end of the day, thanks one and all for taking your precious time and being here. Thank you one and all. Thank you so much. Yes, sir.
Thank you. Thank you. We'll see maybe next month with another webinar. Thank you. Thank you.
Yes, sir. Definitely. We'll have this series on monthly basis.
Thank you.
Thank you so much.
Thank you.
Good night.
Hi, good evening, everyone. Before leaving, everyone fill those link for getting the certificates. Even our QCrete people try to fill those links to get the certificates. Good evening, everyone. Once again, kindly fill the link to get the certificates in chat box. The link is posted in chat box.